friends, today we are going to start with the first chapter of 12th standard physics, electric charges and fields. And in this video we are going to discuss about the electric charge. So let's begin. So let's suppose that we have two glass rods and we rub them on a silk cloth. Then we bring them close to each other and we see that they repel each other. So similarly, if we take two plastic rods and we rub them on cat's fur and we bring them close to each other, and again we see that they repel each other. After that, we take one of these glass rods and one of these plastic rods close to each other, and this time we see that they attract each other. Alright, so let's remember these observations. And let's move on to the next observation. Now we take one of these glass rods and move it close to this metal ball, which is suspended from this rigid support with the help of a nylon thread. So initially there is attraction between the metal ball and the glass rod, but if we touch the metal ball with the glass rod and we separate them, and again we bring glass rod close to the metal ball, this time we see that there will be repulsion between the metal ball and the glass rod. So people observed such phenomena for centuries and they came to some conclusions. And conclusions are: bodies acquire electric charge on rubbing. There are two kinds of electric charges, and like charges repel and unlike charges attract each other. So these are three conclusions. Now the two kinds of electric charges were named positive and negative by American scientist Benjamin Franklin. So he called charges appearing on the glass rods to be positive and charges appearing on plastic rods to be negative. So question is, why do bodies get charged on rubbing? So nowadays we know that everything is made up of atoms, and atoms have a positively charged nucleus and negatively charged electrons surrounds the nucleus. Now when we rub one body against another body, some substances have tendency to lose electrons and some substances have tendency to gain electrons. So the substance which gains electrons, which are negatively charged, becomes negatively charged, and the substance which loses electrons becomes positively charged. Alright. So when glass rod is rubbed with silk, glass rod loses electrons and silk gains electrons. That's why glass rod becomes positively charged and silk becomes negatively charged. And when plastic rod is rubbed with cat's fur, plastic rod becomes negatively charged and cat's fur becomes positively charged. And since like charges repel and unlike charges attract each other, when we bring two glass rods close to each other which are positively charged, they repel each other. Similarly, two plastic rods, if we brought close to each other, then they repel each other. And if we bring one of the glass rod and one of the plastic rods close to each other, they attract each other because they are unlikely charged. Alright. Now let's see what happens in the second experiment. So here we have a positively charged glass rod which we bring close to this metal ball, and metals have huge number of free electrons moving freely inside their cores. So when the glass rod is brought close to the metal ball, the electrons from the metal ball get attracted by the glass rod and they gather on this side of the metal ball. Alright. So the other side of metal ball has lack of electrons and therefore it becomes positively charged. Now there is a force of attraction between this positively charged glass rod and these electrons, and there is a force of repulsion between these positive charges and the positively charged glass rod. But since negative charges are close to the glass rod compared to these positive charges, the attractive force due to these electrons dominates over the repulsive force due to these positive charges, and therefore initially there is attraction between the glass rod and the metal ball. But now when we touch this metal ball with the glass rod, what happens is these electrons get attracted by the glass rod and they enter the glass rod. Alright? And this keeps on happening till the time there is uniform distribution of the charges. But now when the metal ball loses these electrons, there is imbalance between positive and negative charges, and therefore it becomes positively charged. Alright? And glass rod is also positively charged. So now what happens when we separate the two, the metal ball and the glass rod, and again we bring glass rod close to the metal ball, both are positively charged, and therefore now there is repulsion between the two. Now we have seen that the bodies can be charged if two uncharged bodies are rubbed against each other, or when an uncharged body is touched with a charged body. There is third method of charging, and it's called charging by induction. So let us see that. So let's suppose that we have two metal balls and they are mounted on these plastic stands, and we keep them in contact with each other. Then we bring this glass rod which is rubbed on silk close to the first metal ball. So now what happens is the free electrons from both of these metal balls, they are attracted towards the glass rod and they gather on this side of the first metal ball, and therefore this side of second metal ball lacks electrons, and therefore it becomes positively charged. Then what we do is we separate the two metal balls holding the plastic stands, and we take care that we don't touch the metal balls. So we have separated the two metal balls holding the stands, and now what we see is even if we separate the two metal balls, electrons remain on this side of the first metal ball because they are attracted by the glass rod, and therefore now the first metal ball is negatively charged and the second metal ball has lack of electrons, and therefore it is positively charged. So earlier both the metal balls were uncharged. These charges are created or they are induced when we bring this glass rod close to the metal balls, and that's why this method of charging is called charging by induction. Now we can move this glass rod away. So what happens is there is uniform redistribution of charges on both the metal balls. So negative charges are uniformly distributed on the first metal ball, and the positive charges are uniformly distributed on the second metal ball. So this is charging by induction. So in this case we had to take two metal balls for charging both of them by induction. Now let's see how can we charge a single metal ball by the process of induction. Now let's suppose we have this metal ball mounted on a plastic stand, and there is this wire connected to the metal ball, and there is another wire which goes straight into the ground. And if we press this tap key, a contact is made between the metal ball and the ground. Alright? And now we bring this plastic rod which is rubbed with cat's fur close to this metal ball. So now the plastic rod is negatively charged, and therefore what happens is the free electrons from the metal ball, they are pushed on the other side of the metal ball and they gather on this side of the metal ball. And therefore now this side of the metal ball lacks electrons and therefore it becomes positively charged. Alright, so now there are positive charges on this side of metal ball and negative charges on the other side of the metal ball. And now what we do is we tap this key. So the contact is made between the metal ball and the ground, and therefore now what happens is these electrons which are gathered on this side, they flow through this wire to the ground. Alright, and therefore this side has no charges. Then what we do is we untap the key and then we move the plastic rod away so that there is uniform redistribution of positive charges over the surface of this metal ball. So this is how we can charge a single metal ball by the process of induction. Finally, let's look at some properties of electric charges. And first property is additivity. So the electric charges follow scalar rules of addition. That means if we have n number of charges on this body, q1, q2, q3 up to qn, the total charge q total is just equal to the algebraic sum of all the charges present on that body. So q total is equal to q1 plus q2 plus q3 plus up to plus qn. The second property is quantization, and it says that the electric charge comes in discrete amounts, and what it means is that the bodies cannot have any arbitrary charge. The minimum possible charge a body can have is fixed, and it's equal to the charge on one electron or one proton, and its magnitude is 1.602 multiplied by 10 raised to minus 19 coulombs. So when we rub one body against another body, for an example glass rod with silk, one body loses electrons and another body gains electrons, and therefore the charge transferred will be in multiples of the charge on one electron. Alright, so if n electrons are transferred from glass rod to silk, the charge transferred, let's suppose it is q, it will be equal to n times the charge on one electron, and that is n times of E. Alright, so charges come in discrete amounts, they cannot have any arbitrary value, and the minimum possible charge a body can have is equal to the charge on one electron or charge on one proton, and any charge a body can have it should be equal to n times of E. Alright, in multiples of E. And the last property is conservation of charge. The total charge of an isolated system remains conserved, and it's because charge can neither be created nor be destroyed. It can be only transferred from one body to another body, and therefore if we have a closed system, a system which is isolated from its surrounding, then the total charge in that system should remain constant. Alright, let's look at an example of conservation of charge. So in beta minus decay, one of the neutrons from the nucleus gets converted to one proton and one electron. So the total charge on the left hand side of this equation is 0, because we know neutron carries no charge, and charge on proton is E 1.6 multiplied by 10 raised to minus 19 coulombs, and charge on electron is negative of that, it's minus E, so total charge on right hand side is also 0. Alright, so we see that this reaction respects conservation of charge.